Hi, I'm Erica, a customer service representative. Today I'll be providing you with an introduction to air-cooled and water-cooled chillers. It's important to know some basic information about chillers while you are talking to your customers about their chiller equipment and helping them order the right parts. Let's review the objectives of this module. First, I'll explain the basics of a refrigeration system. Next, I'll identify the main components of a chiller. And finally, I'll describe how air-cooled and water-cooled chillers function. Here are some definitions that you'll need to know. Heat is a form of energy. It flows from higher temperatures to lower temperatures. A refrigeration system removes heat from where it's not needed. A chiller is a piece of HVAC equipment which acts as a source of cooling. There are four main components which exist in both air-cooled and water-cooled chillers. Click each button for a description. The compressor lowers the pressure of the refrigerant in the evaporator so that it boils and raises the temperature and pressure of the refrigerant gas. It also circulates the refrigerant in the system. There are a few types of compressors that are commonly used in the HVAC industry. Scroll, which is air-cooled, screw, which is both air and water-cooled, centrifugal, which is water-cooled, and absorption, which actually doesn't use compressors. The condenser transfers heat from the refrigerant to the outdoor cooling medium, either air or water. It also condenses the refrigerant, changing it from a gas to a liquid. The evaporator transfers heat from the cooled air or water through the boiling process of the refrigerant. The expansion valve drops the pressure of the refrigerant liquid from high to low pressure. This separates the high and low pressure sides of the system. Take a look at the graphic on this page. The compressor takes the low pressure vapor from the evaporator and compresses it into high pressure vapor. The pressurization raises the saturation temperature, allowing the vapor to be condensed at a higher temperature. The condenser, a heat transfer device, removes the heat that has been added to the refrigerant in the evaporator and the heat of compression by transferring the heat to a medium which is lower in temperature, such as air or water. The expansion valve performs two functions. It controls the flow of the liquid refrigerant between the condenser and the evaporator while dropping the high-pressure refrigerant to a lower pressure used in the evaporator. The evaporator, which is a heat transfer device, allows the low-pressure liquid refrigerant to absorb heat from the indoor air, changing the refrigerant into a vapor. Click a chiller type for more information. Click the highlighted points to see the major components, an exploded view of it if applicable, and a list of parts that are most often needing replacement. In an air-cooled system, unlike a water-cooled one, a fan creates the movement of air across the heat transfer coil. The heat transfer process changes the refrigerant from a hot vapor into a cooler liquid in the condensing coil. Here is a diagram of the inner workings of an air-cooled chiller system. You can see the air-cooled chiller locations from this view and also where the air handling units are. The pump circulates chilled water from the evaporator to the air handling unit. We will talk a bit more about air handling units in the water-cooled chiller section. Air-cooled chiller maintenance. Air-cooled maintenance is not complex and usually limited to regular lubrication of the fan and motor bearings and the cleaning of coils. However, these units are usually on the roof of a building, so they may be difficult to reach, which can inhibit regular maintenance. Click a chiller type for more information. Click the highlighted points to see major components, an exploded view of it, if applicable, and a list of parts that are most often needing replacement. A water-cooled system uses large quantities of water, which are usually reclaimed in mechanisms such as a cooling tower. Large commercial chillers are usually water-cooled, as these are more efficient. Click each number to see the water-cooled chiller in action. The air handling unit moves the warmed air out of the space. The warm air flows over a cooling coil, and then the newly cooled air moves back into the space. Air handling units are used by both air-cooled and water-cooled chillers. Cooling towers work with water-cooled chillers only. In the chiller, the warm water from a condenser flows into a cooling tower, which cools warm water down. Inside the cooling tower, the warm water flows up to a certain height and then it travels downward. There are fans at a particular level which cool the air when it passes, which then cools the water. Here is a diagram of the inner workings of a water-cooled chiller. You can see the component locations, the air handling units, and the cooling tower. Water-cooled chiller maintenance. Water-cooled chillers require cleaning from algae and bacteria. Scales on tubes are removed by using an acid compound. Proper water treatment is also critical to the operation of the condenser. Water-cooled chillers are located inside of a building, so they are usually better maintained due to being more accessible. Let's review what we've learned today. The basics of refrigeration. Click on each card to read some information that was covered today. The main components of a chiller. Click on each card to read some information that was covered today. Review these facts about air-cooled chillers that were covered in today's training. Review these facts about water-cooled chillers that were covered in today's training. Now it's time for a short quiz. There will be no audio during the quiz. Good luck! Congratulations, you have completed this module.